Hello and welcome to a new Axelent Safety webinar. I'm Atlanta Derek Davies, Order Planning Manager here at Axelent AB in Sweden. This time we will look into some recent changes to regulations and standards dealing with machine safety. With us today is Matthias from the Axelent Safety team. Hi Matthias.
Hi Atlanta and everyone tuned in. There is indeed quite a bit of movement in machinery safety standardization both here in Europe and in North America. You might have heard that the EU has published the machinery regulation, and almost at the same time in North America, two new standards have been published, or two new versions of existing standards, B11.0 for the USA and for Canada Z432.
I believe ANSI B11.0 and CSA Z432 are equivalents to the international standard ISO 12100. Is that right? And what is new?
Yes, that's right. The USA and Canada have both adopted most of the ISO standards on machinery safety. But when they integrate information from these into their own national standards, then they add something. Now, the new version of the B11.0 contains 14 changed items. Of course, we cannot cover them all here, so let me pick a few that are likely most interesting for our customers. Here are three new requirements from ANSI B11.0. Requirements for safe whole body access to machinery. Requirements for operating instructions. These have been aligned with the new ISO standard on this, EN ISO 2607. And then there's detailed guidance on estimating the severity of injury during risk assessments.
And what does whole body access mean?
The term whole body access refers to something that occurs on very large machinery systems big enough for persons to enter. Nobody will normally do that during automatic operation, because then there is a fence around and the doors will be interlocked so nobody can go in. Or you will have presence sensing devices like light curtains that will shut the system down as soon as somebody tries to enter. But for troubleshooting, maintenance or repair, staff may have to deactivate or shut the machine down and then actually go inside. And once somebody's inside, then operators outside may lose track of that person and restart the system without knowing that somebody's still inside. And many terrible accidents have occurred that way.
And B11.0 has new rules on how to prevent that?
Exactly. You know, here in Europe and also in the USA, many appear to think that it is sufficient to block the doors so nobody can close it behind the person that has gone inside, maybe with a padlock and a safety switch, and then to apply a sign that somebody's working inside. But ANSI B11.0 now adds a requirement that technical measures need to be taken to prevent restart of the system as long as somebody's inside. There are a number of options available in B11.0 and related standards like B11.19 for safeguards or B11.20 for machinery systems that integrate several machines. And here are four of these that are now in the B11.0. Proactive inhibit functions like key transfer systems or trap key systems. Presence sensing devices inside the hazard area. These may range from scanners to contact-sensitive mats, etc. And then there are startup initiation warning systems and escape release on the doors. And finally, a sequential time-limited reset function. Normally, when you press the start button on a machine, it will start more or less immediately. But with the startup warning system, pressing the start button will first cause an audible and visible warning. In this illustration, you see a start and an emergency stop button in several places. And now an operator would press one of those start buttons. Then the warning will start sounding for some time. And then at the end of that time, the machine will start. Somebody who was accidentally locked inside the system could now stop the warning and the start procedure by pressing one of the buttons. To allow for that, you need a sufficient number of stop buttons inside the system. And you can see here we've placed several emergency stop buttons and also a pull rope switch inside the system. The startup warning system is often also combined with so-called escape release switches on the doors. On these systems, the doors are often guard locked, so you can't get out normally. But with these special handles on the doors, they will open from the inside, and an emergency stop command will normally be triggered that way. Now, if you look at this, and then somebody might argue that it would be better to not even start the system in the first place before you are sure that there's nobody inside. A sequential time-limited reset function might help. Sequential time-limited reset function is a rather strange term, and it's also new. So let me explain. Sequential reset means that the operator must press several reset buttons before he can press start. So he would press the first reset button, and then a timer starts running. And then he must walk along the system to the next reset button in the sequence. The time he uses to do that is monitored. And then he walks on to the last reset button. In this case here we have 3, and presses it. And if he has pressed the buttons all in the right sequence and has done so during the set monitoring time, then he can finally press the start button. What's the point of that? The point of that is to make the operator walk alongside the system and look inside to check if somebody's in there still. And making him press several buttons in a row will ensure that he has looked at every section, every portion of the system before he starts it.
That seems like a clever setup. You also mentioned that new information on risk estimations has been added to ANSI B11.0.
Yes, as part of risk assessment, we do something that's called risk estimation. And one of the risk elements, in fact the most important one that we have to estimate, is the seriousness of injury. In European and ISO standards, we only differentiate between reversible injury, lighter, moderate injury that you can be healed from, and irreversible injuries, such that are permanent or even fatal. When you look at this little extract from the ANSI B11, you see that it contains more information on how to estimate risks properly. In the example, you see bruising and also burns, and you see classified different types of injury as either catastrophic, serious, moderate, or minor. And this will help you to judge more correctly on the seriousness of injury. We might also use this in Europe.
This was interesting news regarding changes in the US standards. Let me follow up with a general question. Would you say that US and Canadian machine safety standards are very different from the international and European standards?
Well, one of the major differences between ISO standards and North American standards is that North American standards include requirements for users and operators of machinery. In Europe, we keep the two spheres clearly apart. We have one set of requirements for the manufacturers of machinery and a different set of requirements for operators and users. As is quite well known, ISO and ZEN, the European Standards Institute, have devised the ABC system of machinery safety standards. You can see it here. And both ANSI and CSA have adopted many of these standards. but they add national rules to them by means of ANSI B11.0 or CSA Z432 and numerous other standards. Interestingly, ANSI is using a US-specific ABC system now. ANSI B11 includes a long list of standards which address general machine safety topics. That would be Type B standards. B11.19 is likely the most important of these because it contains dozens of excerpts from ISO standards, and the rules are often identical or very similar to those of ISO. And there's also standards for specific types of machinery. These are the Type C standards. Regarding this, one must say, however, that the differences between ISO and European standards are a lot bigger.
Thank you for the overview. In future webinars, we will explain some of those differences.
Yes, that may indeed be interesting for many of our listeners today. But let me now move on to the big change that has occurred here in Europe: publication of the machinery regulation. The current machinery directive is very well known around the world, and in the past 13 years it has gained recognition as a type of gold standard, not only here in Europe but also in many other parts of the world. And the EU has now modernized this and republished it as a machinery regulation.
Why is it called a regulation now instead of a directive? That sounds stricter, is it?
No, you couldn't say that. It's really generally stricter. Some of the requirements have been rephrased, clarified, and thus may appear a little stricter. The new name is a typical EU peculiarity. Directives like the Machinery Directive and others had to be converted into national laws by each of the EU's member states for them to apply. That means a lot of administrative effort, and it also means differing interpretations of some details. A regulation, however, applies directly in each member state. It is hoped that this will result in fewer conflicting national interpretations. The machinery regulation has been published in June this year and has entered into force on July 19. But manufacturers and others will have to apply it only as of January 2027.
Can you give us a brief overview of what is new?
I sure will. But this is a very lengthy, large document, so let me focus on just a few things that I think are very interesting. To me, the most important changes in the machinery regulation are the extension of the scope of the application, that is, what does the regulation actually apply to, then the adaptation to the new legislative framework. The main consequence is that the regulations now also apply to importers and distributors of machinery. Then there's new risk types that we will have to consider during risk assessment. And one that has been waited for a long time is that now operating instructions may be supplied in digital format. But surprisingly, very few actual requirements have been changed or added. So you could say it's more of a renovation than a revolution compared to the Machinery Directive. Imagine somebody having an accident inside large machinery, for instance, during setting or maintenance work. You would want to rescue the person quickly, but trying to do so, you would find that space is lacking to carry him out on a stretcher, as is shown here. The machinery regulation contains two new requirements that relate to this problem. One is found in Annex 3, Section 117, where the regulation says about operating positions that the exit shall allow rapid evacuation. Moreover, when applicable, an emergency exit shall be provided in a direction which is different from the usual exit. This does not directly refer to large machinery, but may be applied to it. The second requirement is found in section 162. Here a paragraph has been added which directly refers to large machinery. In the case of machinery or related products into which persons shall enter for operation, adjustment, maintenance, or cleaning, the machinery accesses shall be dimensioned and adapted for the use of rescue equipment in such a way that an emergency rescue of the person is possible. In brief, this means that manufacturers of large machinery must provide for suitable emergency or rescue exits. This may be ensured, for instance, by providing an additional exit, as shown here. Or it may be achieved by providing for additional space, so typical rescue equipment can be used. In the second example, the manufacturer increases the distance between machine parts and the fencing and provides for a wider door.
Could you briefly bring us up to date on the other changes that you mentioned earlier?
Yes, of course. One very important change is the extension of the scope of application of the machinery regulation when compared to the directive. The machinery regulation now also applies to remodeled used machinery. If somebody substantially changes a machine's safety concept or adds new hazards, he must comply with the regulation. And the new regulation also applies to safety-related software, like control systems for autonomous vehicles and robots. And if this software includes artificial intelligence, so-called AI functions, it will even need certification by a testing agency. And then there's a third change, which actually closes a loophole. Machines only lacking control software will in future have to be CE marked. Another big change concerns risk assessments. We will have to look at a few additional risk types in the future. Risks from collaboration of humans and autonomous machines. This type of risk occurs in robots, mobile robots, and autonomous vehicles which plan their own operation. Then there's ergonomic risks, environmental risks, and so-called cyber risks. Many machine control systems today have digital interfaces, such as a USB slot, a LAN connection, Bluetooth, and Wi-Fi. And all of these interfaces could be used to corrupt the software running on the controller. If safety-related software is corrupted, that could become dangerous. Just imagine somebody switching off monitoring by a light barrier or changing the maximum temperature or pressure limit set. This could result in very bad accidents. Another scenario that has become more realistic with the new hot and cold wars is that an attacker may try to shut down or even destroy machines in critical infrastructures, like waterworks, power stations, or telecommunications networks. To mitigate such risks, the EU will publish a so-called Cyber Resilience Act. It will be of much broader scope, however, than the machinery regulation is in this field. What will manufacturers have to do in their risk assessments regarding cyber risks? In brief, they will have to determine all interfaces through which access to safety-related software could be established. They will have to study the nature of possible attacks, design measures for protection, These could be standard measures like password protection and different user right levels, but also IT security components and software. Then they would have to integrate means to detect attacks, plan for countermeasures, and develop procedures for restoring proper function. There are some international standards already that will help to do all this. ISO TR 22100-4 and IEC 62443, Part 3, Subpart 2.
That sounds like a complex task that will take some time.
Well, that's obviously true. And there's a lot more work to do until 2027 when the regulation finally applies. So that's why I think that it's not a very good idea to sit back and wait for the date to come by. But machinery manufacturers should now study what the changes mean for them, draw up an action plan, and then follow it.
Thank you for all your input today, Matthias. As we know, machine safety is progressing constantly. New technology needs new or adapted safety rules. Axelent is at your side to support you. Goodbye for now, and remember, stay safe and stay up to date.